Jai Hind viewers, myself Dr. Sukhwinder Singh, Associate Professor in Indian Department from Ajay Kumar Garg Engineering College. Today I am going to discuss the very next topic of a DC machine from Unit 2, that is commutation process. The importance of commutation for DC machine is that when we are going to give the current as a motor, in the case of motor, then we need to have the carbon brushes and commutator segments. And for the DC generator, when the AC induced EMF in the armature is coming to the external circuit, that comes through the split ring or commutator segments, so that it is converted into unidirectional. That may be pulsating DC, and we can rectify that DC into the pure form with the next circuit, that is known as filtering circuit. Let's discuss with the commutation process, how the commutation process takes place and how the reversal of current takes place in the armature winding when the armature windings are moving or coming across the carbon brush position. As we have discussed in the previous lectures, that armature reaction has a very important role, and it may affect the performance of the DC machine, because due to the armature reaction there will be an induced EMF at the carbon brush position or magnetic neutral axis, which when they are mounted on the geometrical neutral axis, and they can give the spark when the particular commutator segment pass on, or you can say the coil is going to the commutation process, then there will be a sparking if there will be some armature reaction, and due to that armature reaction there is a flux which interlinks with the particular winding, and due to that particular EMF induced in that winding, that cause the spark in the brushes. So let us start with the commutator segment process. Let's come to the next point. Commutator. What is commutator? You can see here in this side. Commutator is a rotary electric switch. Certain type of electric motors and electrical generators that periodically reverse the current direction between the rotor and the external circuit. That is the main purpose or main function of the commutator segment. In the case of DC generator, whatever the EMF induced in the armature, it coming out, or you can say when it is going out from the particular armature circuit, then that EMF has to travel through the commutator segments and then through the carbon brushes to the external circuit. And in the case of DC motor, when we have to give the supply, DC supply, then that supply goes to the carbon brushes, after that commutator segments, and through commutator segment it is given to the armature winding. And the carbon brush position is the position where with the help of commutator segments the current reversal takes place. Okay, and it consists of cylindrical composed of multiple metal contacts. They are made up of generally copper, and they are insulated from each other with the help of mica sheets. You can see in this diagram what we have is, this is the carbon brushes, and you can see over here shaft is there and it is rotating. I have taken the particular reference from this particular source. You can see here, and then this is the particular armature windings, and those armature windings are connected to the commutator segment. Each of the winding is connected to a particular commutator segment, and then those commutator segments are connected to the external circuit with the help of carbon brushes. You can see over here the carbon brushes are mounted on the commutator segments. You can see this, and this particular whole thing is rotating along with the shaft, and then the a particular current conduction takes place with the help of carbon brushes. Or carbon brushes is only the medium through which we can give the current as a DC motor, and will take the voltage output as a DC generator. So you can see in this diagram, these are the commutator segments, and these are for each of the winding where the start and end connection of the winding is connected. And these are the particular copper bars, and those bars are insulated from each other with the help of mica insulation. Now let us proceed how the commutation process takes place, how the current reversal takes place when those commutator bars comes across the carbon brush position. That is the main important point we have to discuss. Okay, let's go for the next slide. Now see here, what I have mounted is, let us suppose we have now see here, what we have is, this is basically the armature, and all the armature conductors, or you can say windings, those windings are connected to each of the commutator segments like this, and I mounted over here is a commutator segment like this. These are the commutator bars as I have shown in the previous slide, and each of the bar is connected like this. From here another winding, here another winding, it is connected to the commutator bar like this. So this is the main diagram, and all the bars are open circuited. Okay, those bars get short circuited, or you can say current conduction takes place only when these commutator bars are going to pass through the carbon brush position. And for the, you can say, efficiency point of view, for the effective commutation, what we need is, there is no sparking when the armature coil going to pass through the carbon brush position. That is the first basic requirement. And for that, we need to ensure that there will be no EMF induced in that coil, which is going under the commutation process like this. Suppose this particular coil is going to under the, you can say, process of commutation, then we need to ensure that there will be no EMF. Okay, generally the EMF induced in the coil through the two main reasons. First of all, due to the flux linkages across the coil due to dynamic effect. We know that this particular armature is under the effect of stator's magnetic field, and due to the armature reaction, we know that armature reaction is cross magnetizing and demagnetizing effect we have, and the resultant flux may link, and the particular magnetic neutral axis is going to shift. But we can do another methods, or we can apply the another methods to remove that armature reaction, or to minimize that armature reaction, and we have to insert the carbon brushes at the geometrical neutral axis. Okay, whatever the armature reaction is there, we are applying the methods like compensating winding is there, interpoles are there. They will ensure to reduce the armature reaction, so that the minimum flux will link at the winding when those windings comes across the carbon brush position, so as to have the minimum induced EMF or near to zero induced EMF we want to ensure. Okay, now see here, that is due to the dynamic EMF which will be induced in this particular coil, which is going under the effect of commutation. Another one is due to the self-induced EMF. The next very important point is self-induced EMF. Induced EMF. Okay, induced EMF in the coil when that coils comes in the process of commutation, or when that coil pass through the carbon brush position. How we can reduce that kind of self-induced EMF? Self-induced EMF is the EMF which induced in the coil itself when the current reversal takes place. Okay, let us suppose the current flowing through the coil is in one direction. When it comes across the carbon brush position, it has to change its direction, and that comes reverse, and that is known as the change in current. Okay, let us suppose I'm showing over here, you can see, let us suppose the current is in positive direction, like this is positive I is there, positive I is there, and when it comes through the carbon brush position, its current is going to reduce and it is reaches to the zero level, and then it reaches to the minus I. Okay, or you can say current reversal takes place or commutation takes place in that particular coil. But what will happen due to this change in current? The total change in current is di is equals to plus I minus of minus I, it becomes 2I. This is the total change in the current. And due to that total change in the current, what we have is, we have the self-induced EMF. Like this, self-induced EMF in the coil, induced EMF is given by the L di by dt. Now we have the 2I change in the current, that becomes 2 L I by T, whatever the time taken for the change of that particular current. So that also cause the sparking at the carbon brush position. That's why we need to ensure the minimum EMF induced when the coil passes through the carbon brush position. So that is the requirement for effective commutation. Now see how commutation takes place. Now see, in this particular diagram, this is the starting point. You can see over here, there are particular 1, 2, 3 are the commutator segments. To these commutator segments, the coil A, B, C and D are connected like this. You can see this particular coil end is here, and start is here. The second coil, that is the B coil. And for end and start of these particular windings or coil is connected to this particular commutator segment 1. This commutator segment is insulated from the next commutator segment with the help of mica insulation. Which kind of insulation we are using? Mica insulation. Okay. Now see, this is the second commutator segment. It is open circuited. This one is open circuited. Which commutator segment is short circuited? Sometimes in the books there is written that now the particular coil is short circuited. Okay, that means now the brush position comes across that particular coil. Okay, that particular commutator segment. Actually, this part, armature winding part, commutator segment part, both are rotating. Okay, let us suppose carbon brush position is fixed. This is the fixed and it is the part of stator. Carbon brush is the part of stator. Only this part is moving. This part is moving like this. Okay, we have to have the motion in this direction from left to right. We are considering that this whole part is moving from left to right. Okay, that's why this carbon brush position is going to contact with the second commutator part. Okay, accordingly there will be a current conduction. Now see here, the second, this is also open circuited. These two coils C and D. D has the current of 20 ampere which is coming in this direction, and ABC has the current direction in this side. Okay, all these coils are open circuited. That's why the 20 ampere current remains same. And when this commutator segment 3 is connected to the carbon brush position, or this particular segment comes across the carbon brush position, then the current conduction takes place through this commutator segment only. Now we are considering the case when the 100% contact of the carbon brush with the third number commutator segment. That's why the full current is flowing in this direction. 40 ampere is there, 20 ampere is coming from the C coil, and 20 ampere is coming from the D coil. This is the first instant when the 100% contact of the carbon brush with the commutator segment number 3. Now come to the next point. As this motion is in this direction, it moves in this side, all the coils and commutator segment. Let us consider now we have the 1/3 portion of the carbon brush is in contact with the commutator segment 2. See here, commutator segment 2, and the rest of the part or the maximum part is still with the commutator segment 3. What will happen? Now the current distribution takes place in such a way that 20 ampere is coming from this D coil, it enters over here, and 10 ampere is in the C coil remains, and due to the carbon brush is now making the contact with the second number commutator segment, that's why 10 ampere is also coming from this side, and the total current again is 40 ampere. There is no change in the magnitude of current, okay, because it is a unidirectional current, it remains unidirectional, and the only reversal of current takes place in the coils which are mounted on the armature core, or you can say armature coils. Now 10 ampere is from here, it is comes out to be 30 ampere, this remains 10 ampere, because 20 ampere is distributed like this, 10 ampere in this coil and 10 ampere in this coil. That's why we have this 40 ampere is again. Now come to the third stage, when half of the carbon brush making contact with the commutator segment 3 as well as the commutator segment 2, that's why it is equally contacting the both commutator segment, then the current takes, you can say current distribution takes place in such a way that coil C has zero current, okay, and 20 ampere is coming from this particular D coil comes over here, and 20 ampere coming from B coil is comes over here. That's why the total current again comes out to be the 40 ampere. Now our stage has reached when the current reaches in the coil C is 0. It means our C coil is under commutation process, okay. In this coil, commutation is going to happen for this particular movement. Now see, in the next, you can see over here again, the movement is in this direction, that's why the maximum contact is now with the commutator segment 2, and the 1/3 remains with the, or 1/4 remains with the commutator segment 3, and due to that current distribution takes place in such a way 10 ampere is only in coming from the third say commutator segment, and this 20 ampere is comes over here. And now previous case we have the zero current, and now the current reversal takes place, and current in this C coil now in this side. In the previous, when we started the commutation process, current through the C coil is in this direction. You can see 20 ampere is in this direction. Then it decreases in the C coil 10 ampere, after that 0, it reaches to 0 also. Now in this case current reversal takes place and the current direction now shifted to this side, and that's why 10 ampere is now moving in this direction, and 30 ampere is coming from here, and here 10 ampere remains, and total current is again 40 ampere. Okay, this is how the current reversal takes place in the commutating coil. Why we called it is commutating coil? Because that coil is going under the process of commutation with the help of carbon brush position. In the last, you can see in this particular diagram, the maximum means 100% contact is now with the 2 number segment, and that's why we have the current distribution like this. For the effective commutation, if we have the ideal commutation, we can say ideal commutation. In the ideal commutation, when the brush position make the contact with the commutator segment 2 or 100% contact is there, for ideal commutation, we are considering there is no spark, there is no EMF across the coil. Either it is dynamic or self-induced EMF, both are minimized or considered to be 0. Both the EMFs are considered to be 0 for the ideal commutation. But in the actual practice, what will happen, due to that particular self-induced EMF, or maybe due to some disturbance through the dynamic induced EMF, there will be a spark. And due to that spark, or for the actual case, we have considered over here that 35 ampere is coming from here, and in the coil C, current reaches to the, you can say in the reverse direction or negative direction, 15 ampere, and here it is 5 ampere is coming. Why it is 5 ampere? Because it current passes through the air. Okay, due to that highly induced self-induced EMF, okay, because the rate of change of current is very high, there will be a air gap, and that air gap, due to this high rate of induced EMF or high magnitude of induced EMF, air get, you can say, ionized, and due to ionized air, that will create the spark, and through that spark 5 ampere is coming from this particular third number commutator segment. That happens in the inefficient commutation process. Okay, or you can say, or practically it is near to 5 ampere. We are considering just an example to show you that what will happen in the actual condition. Now for the effective commutation, we need to have particular interpoles are there, so as to reduce this effect, as well as we have the compensating winding effect also there, or resistance commutation is there. There are so many methods are there in to improve the commutation process. Now come to the next. In the commutation process, what we have observed, if we draw the graph for the commutation process, from where we have started in the coil C, current at the starting instant is 20 ampere. We are considering that is the positive. This is 20 ampere in the positive direction. Okay, as the time lapse, this particular, or you can say as the movement of armature circuit is there, this current reduces to 0 when passing through the Karm brush position, and it reaches to 0 level. Okay, then in this coil number C, current reaches to 0, and after that we have considered another case when the current reaches to, in the reverse direction, we are considering in the reverse direction is minus 10 ampere. Okay, or 10 ampere in the reverse direction. Reverse direction means like this. In the fourth case or fifth case, it comes out to be 10 ampere in the reverse direction. And after completion of the commutation process, you can see over here, completion of the commutation process, it reaches to almost minus 20 degree, minus 20 ampere. Okay, so this is the particular commutation process, and this is the time taken for to complete this commutation process, that is supposed to be T. So how we can explain the commutation process with the help of previous diagram, as we have discussed earlier, and with this particular graph. Okay, and for the time being, sometimes what will happen, due to the ineffective commutation, current is reaches to, suppose it reaches to just 35 ampere from this particular coil, and rest of the through air gap, or so can air ionization, or the ineffective commutation, and after that it should be completed to minus 20 ampere. So this is the for you can say delayed commutation. Delayed commutation means when the contact under the effect of you can say commutator segment is under the effect of complete 100% Karm brush position, the current still in that particular coil is only 35 ampere, and rest of the coming from the air and due to the spark. That's why it is known as delayed commutation. So this is the whole process, or you can say explain with the graph also what is the commutation process and what is the significance of commutation in the DC machines. It happens in both the cases, DC and DC motor as well as DC generator. So that's all for this is all about the commutation process. Thank you so much for watching this video. Thanks.